Assalamualaikum and a very good day. So now we are in week 8 part 3 video. We still under topic coordinate system, but now we go to subtopic equation of plane. What you will learn class in this topic is equation of plane in R3. First, you need to know about normal vector. Normal vector here is given by n equal to ai plus bj plus ck. That contains the point here x0, y0, z0, and if we have here this vector and this point, we can write our equation of plane in terms of two forms. The first form here is point normal form, which is given by ax minus x0 plus by minus y0 plus cz minus z0 equal to 0. Means that here our A, B and C are obtained from this normal vector and our x0, y0, z0 are obtained from this point. And then we have a second form which is standard form, which is can be written as ax plus by plus cz plus d equal to 0. In this case, actually, we just expand our point normal form, which is here. If I expand this point normal form equation, I will have ax minus ax0 plus by minus by0 plus cz minus cz0 equal to 0. And then I can write here ax plus by plus cz plus negative ax0 minus by0 minus cz0, which is equal to 0, and this part we can write as d. That's why we got here a standard form which is given by ax plus by plus cz plus d equal to 0. Conversely, a normal vector to the plane ax plus by plus cz plus d equal to 0 is given by this normal vector. Means that this one is also normal vector to this plane. Now we go to the second theory, that is the normal vector of a given plane. Previously, we have equation of plane with coefficient a, b, c and d be constants, with a, b and c not all 0. Then the graph of the equation ax plus by plus cz plus d equal to 0, where d here, as mentioned previously, it is negative ax0 plus by0 plus cz0. So, based on this one, we can write a normal vector to this equation of plane, which is the normal vector is given by ai plus bj plus ck. Means that to write the normal vector, you just take this coefficient a, b and c. Now we go to this example 1. The question asks us to find an equation of the line. Please take note that the question asks us to find the equation of the line, not yet equation of the plane, that passes through the point Q1, negative 5, 3 and is orthogonal to the plane 2x minus 3y plus z equal to 1. In this case, how to solve this one? Based on this, we need to find equation of line. So we know equation of line is given by x equal to x0 plus at, y equal to y0 plus bt, and z equal to z0 plus ct. In this case, we know that we have here a point x0, y0, z0 equal to 1, negative 5, 3. And then now we need to find our a, b, and c. As mentioned previously, actually orthogonal is equal to normal vector. It is normal to the plane. So from here we can get this a, b and c from this equation. Whereas we have here in general our equation of plane is given by ax plus by plus cz plus d equal to 0. If I write this equation of plane in terms of this form, I have here 2x minus 3y plus z minus 1 equal to 0, where here our a is 2, our b is negative 3, and our c is 1. so that I can write the equation of plane here, x equal to 1, x naught plus this a is equal to this a. So plus 2t, y equal to y naught negative 5 minus 3t. So this b is given by this b, and z equal to 3 plus t. So this is the equation of line that passes through this point and orthogonal to the plane 2x minus 3y plus z equal to 1. Question number 2. We need to find an equation for the plane that contains the point P and has the normal vector n, which is given by A and B here. So now, based on this, if we solve for A, we know that our x naught, y naught, z naught is given by negative 1, 3, 5. And we know our n is 2i plus 4j minus 3k. So in this case, 2 is A, 4 is B, and this 3 is negative 3 is C. I can write the equation of plane in terms of ax minus x naught plus b y minus y naught plus c z minus z naught equal to 0. So in this case, I already have a, b, and c. I can substitute in this equation. So I have here 2x minus my x naught is negative 1. So minus minus become positive. So plus 1 plus b, so plus 4, y minus 3 plus c negative 3 for c, z minus 5 equal to 0. When I expand this one, we will have 2x plus 2 plus 4y minus 12 minus 3z plus 15 equal to 0. So we will have 2x plus 4y minus 3z plus 5 equal to 0. So this is equation of plane when we have here coordinate P negative 1, 3, 5 and normal vector equal to 2i plus 4j minus 3 minus 3. Now we go to this example B. We need to find equation of the plane that contains points P, 1, 1, negative 1 and normal vector equal to negative I minus 2j plus 3k. In this case, understood, x naught is 1, y naught is 1, and z naught is negative 1. And from this normal vector, we can get our A equal to negative 1, B equal to negative 2, and C equal to 3. So now we can write the equation of plane as A, x minus x naught, plus B, y minus y naught, plus C, z minus z naught equal to 0. When we substitute A, x naught, B, y naught, C, z naught, we can get here A is negative 1, so negative x minus 1. B is negative 2, so negative 2 times y minus 1 plus C is 3, 3, z minus negative 1, so plus 1 equal to 0. When we expand this equation, we can have negative x minus 2y plus 3z plus 1 plus 2 is negative 2 times negative 1 plus 3 equal to 0. So we will have here negative x minus 2y plus 3z plus 6 equal to 0. So this is our equation of plane for this P1, 1, negative 1 and normal vector negative I minus 2j plus 3k. Example 3 asks us to find the standard form equation of a plane containing 3 points P, Q, and R. Example, first we need to identify our x naught, y naught, and z naught. So our x0, y0, and z0, you can use either P, Q, and R points. Let's say here I use a point P as my x0, y0, and z0. So I have -1. And the second thing, we need to find normal vector, which is given by AI plus BJ plus CK. Please take note that in this example, we have point P, Q, and R. So now, for example, here, if you recall back for vectors, let's say this is our 2R, a normal vector is given by this vector. And how to compute this normal vector, which is this one equal to PQ cross PR, means that we need to find first our vector PQ and also vector PR. How to compute vector PQ? We have here 2 points, so the second point Q minus the first point P. We will have here 0 minus -1, so plus 1I, plus -3 minus 2J, plus 2 minus 1K, means that we will have here our PQ I minus 5J plus K. And then we compute here PR, which is this point R minus point P. We will have here 1 minus -1I plus 1 minus 2J plus -4 minus 1K. We will have here 2I minus J minus 5, and then we need to compute normal vector, which is given by PQ cross PR. And this one is given by determinant of the matrix I, J, K. And we have here coefficient of PQ vector 1, -5, 1. And then 2, -1, -5. Means that here we will have -5, 1, -1, -5I minus determinant of 1, 1, 2, -5J plus determinant of 1, -5, 2, -1K. When we solve this one, we'll got the answer here, which is equal to 26I plus 12J plus 9K. And in this case, this 26 is our A, and 12 is our B, and this 9 is our. So let's write again. We have our x0, y0, and z0 equal to -1, 2, 1. And then we have a normal vector equal to 26I plus 12J plus 9K. So when we want to find the standard form of equation of AX plus BY plus CZ plus D equal to 0, we will form first equation of A, x minus x0 plus B, y minus y0 plus C, z minus z0 equal to 0. So here we will have ax plus by plus cz plus -ax0 minus by0 minus cz0 equal to 0. So our A is 26. Instead, we have 26x plus 12y. B is 12 plus 9z plus -26 times -1, our x0, minus 12 times 2 minus 9 times 1 equal to 0. When we solve this one, we will have here 26x plus 12y plus 9z minus 7 equal to 0. So this is our standard form of equation of plane for this example.